When you think about the end of World War II in Europe, you might picture the German army surrendering, the swastika coming down from government buildings, and the vast machinery of Nazi tyranny grinding to a halt. But there's a chapter of that story that's often overlooked, one that deals with thousands of massive, sophisticated military machines that were suddenly left without a purpose. Across the ruins of Germany, scattered through forests, abandoned on roadsides and clustered around destroyed factories, the Allies discovered an enormous problem that would take years to fully resolve. What on earth were they supposed to do with all of Nazi Germany's tanks? This wasn't a simple question to answer in the chaotic weeks and months following Germany's unconditional surrender on May 7, 1945. By May 1945, when Germany unconditionally surrendered on May 7th after Hitler's suicide and the elevation of Admiral Dönitz to nominal command, the country was littered with Panzer IVs, Panthers, Tigers, Panthers, and countless other armored vehicles in varying states of operational condition. Some were battle-scarred wrecks, barely recognizable as machines to anyone who hadn't seen actual combat. Others were almost pristine, fresh from factories that had been desperately trying to keep up with Allied bombing raids and production demands despite catastrophic losses of industrial capacity. And then there were the truly strange ones, experimental vehicles, incomplete prototypes, and designs that never made it past the drawing board before the war ended in total defeat. The Allies didn't just need to figure out how to dispose of these machines. They needed to decide whether to study them, preserve them, transfer them to allies, or simply destroy them entirely. The answer would be different in each occupied zone, shaped by the priorities, resources, and ambitions of the Americans, British, Soviets, and French. What unfolded in the years between 1945 and 1950 was a fascinating tale of logistics, engineering curiosity, political calculation, and industrial salvage, and it would determine the fate of thousands of remarkable machines that represented some of the most advanced military technology of their era. The shadow of an armored fleet. Understanding what the Allies found. When the guns fell silent in May 1945, Germany's armored forces were a hollow echo of what they had been at the height of the Reich's power in 1943 and early 1944. The war had been catastrophically hard on the German tank industry and the troops who operated those tanks. Years of Allied bombing had struck at the heart of German production with relentless intensity, destroying factories and disrupting supply chains. The Ruhr Valley, where much of the Reich's steel and tank components were manufactured, had been systematically devastated by the RAF and the USAF in strategic bombing campaigns designed to cripple German war production. Factories had been reduced to rubble. Entire production lines had been destroyed. Supply chains had collapsed into chaos. The German synthetic fuel industry, which had been essential for keeping tanks and vehicles moving, had been crippled by strategic bombing campaigns that targeted the specific plants manufacturing synthetic petroleum products. Without fuel, the most technologically sophisticated tank is simply immobile scrap metal. Beyond the bombing, the constant retreat of German forces across multiple fronts meant that tank crews were desperately cannibalizing vehicles to keep others running. An engine here, a gearbox there, optics from one tank salvaged to repair another. By 1945, the German tank fleet was a patchwork of half-functioning machines, many of them crippled by mechanical failure, fuel shortages, or deliberate sabotage by German crews who destroyed their vehicles rather than leave them for the Allies to capture intact. German officers understood that an intact tank in Allied hands was a teaching tool, a source of technical intelligence, a potential template for future tank designs. So they smashed gearboxes. They poured sand into fuel tanks. They burned out engines with thermite grenades. They did everything they could to render their machines permanently useless to the enemy. The actual numbers tell the story clearly and starkly. Germany had produced approximately 47,000 tanks of various types during the entire war, from 1934 through 1945. This figure encompasses everything from small training vehicles to massive super-heavy tanks, from agile medium tanks to specialized tank destroyers and self-propelled guns. The most frequently produced was the Panzer IV, with over 8,500 units built in total throughout the war years. The Panzer III came second, with thousands of examples produced in various configurations. The Panzer II was produced in large numbers early in the war. Tank destroyers like the Stugge III and Jagdpanther were also produced in significant quantities, but by May 1945, the majority of these machines were either destroyed in combat during the desperate final battles, demolished by their own crews in acts of sabotage, abandoned without fuel or spare parts in depots across the continent, or so mechanically unsound that they would never move again without extensive repair in the kind of industrial infrastructure that was now either destroyed or being dismantled. When Allied forces pushed into German territory in those final weeks of the war, they encountered the physical remains of that massive industrial effort scattered across an entire continent. In the Ruhr Valley, in Bavaria, around Berlin, and throughout the German heartland from the Rhine to the borders with Poland and Czechoslovakia, soldiers found Panthers and Panzer IVs simply sitting abandoned in forests, on roadsides, outside ruined factories, and in improvised parks. Many had empty fuel tanks, a reflection of the desperate fuel shortages that had plagued the Wehrmacht in those final months. The German military had exhausted its synthetic fuel production capacity, and no imports were reaching Germany from its erstwhile Romanian allies, who had switched sides. Others had components stripped away, with entire systems removed to keep other vehicles operational during the final desperate months. Some had been deliberately immobilized by their own crews, who had destroyed engines or gearboxes rather than allow their tanks to fall into Allied hands in functioning condition. These weren't just a few scattered vehicles either. We're talking about hundreds, thousands of tanks spread across the landscape in depots, repair shops, and abandoned on the roads from the front lines. American technical intelligence teams found vast collections at places like Oberursel and Geldorf in occupied Germany. The British REMI, the Royal Electrical and Mechanical Engineers, conducted similar surveys at places like Hillersleben and Sennelager, cataloging and securing every vehicle they could locate. Soviet trophy brigades operating across Silesia and advancing deep into Berlin itself recovered enormous quantities of armor from the Eastern Front. The Red Army was particularly interested in capturing intact vehicles and documentation that could teach them about the latest German designs. Entire German tank parks, mobilization depots, and training areas fell into Soviet hands as they advanced westward. The condition of what the Allies discovered was highly variable and often disappointing to planners who expected to find many pristine and serviceable machines. Some German tanks were nearly intact, having been stored carefully and maintained in well-protected locations, but they suffered from worn components that made them mechanically unreliable despite their intact appearance on the surface. Other vehicles had been thoroughly stripped, with radios, optics, and engines removed, leaving only empty steel shells, the tank equivalent of a hollowed-out building with all the valuable materials extracted. Prototypes and factory-fresh hulls often lacked complete systems because wartime bombing and supply shortages had prevented them from ever being fully assembled in the first place. Some vehicles were so badly damaged by shelling and bombing that they were barely recognizable as tanks at all, twisted metal wrecks that had been torn apart by the violence of combat. The Allies found factories and workshops scattered across Germany where operational records still existed, documents that detailed the wartime deployment history of specific vehicles. These records proved invaluable for understanding what had been built, when it had been built, how many had been produced, and where various tank units had been sent. Tank historians could use these records to trace the movements of specific formations and understand the flow of vehicles through the German military system. But many of these records had been deliberately burned in the chaotic final weeks of the war, lost forever to the flames, as German officers tried to destroy evidence of their military operations. The logistical challenge was simply enormous and unprecedented in military history. The Allies now controlled thousands of vehicles scattered across a continent-sized territory. They had to be secured against unauthorized use. They had to be cataloged and inventoried. They had to be stored somewhere with adequate security and protection. The occupation forces had to decide which vehicles were worth preserving for study, which ones should be transferred to Allied nations as military aid, which ones should be used as training targets, and which ones should simply be destroyed completely. This wasn't a problem that could be solved quickly or easily with the resources available at the time. Decisions made in 1945 would shape the work of military engineers and logistics personnel for years to come. By the summer of 1945, most of Germany's surviving armored fleet sat in Allied-controlled yards, guarded by soldiers, awaiting decisions from headquarters about whether these machines would be studied, distributed to other nations, or systematically destroyed. The decision-makers in Washington, London, and Moscow would spend the next 3 years answering that question in distinctly different ways, reflecting their different strategic priorities and military philosophies. The technical curiosity: how the Allies studied German tanks. As the Allies organized their occupation zones in mid-1945, a new priority began to emerge alongside the basic work of collection and security. Military planners and engineers from the United States, Britain, and the Soviet Union became intensely curious about how German tanks actually worked. The Germans had demonstrated remarkable technological innovation throughout the war. Their tanks had powerful guns, excellent optics, and sophisticated armor designs that had forced Allied tank designers to think deeply about what made an effective fighting vehicle. Now that the war was over and Germany lay defeated, the Allies had a unique opportunity to examine this technology in minute detail, to understand the reasoning behind German design philosophy, to test these machines under controlled conditions without the pressures and uncertainties of actual combat, and to learn what lessons might be applied to future tank development. This was a moment that military engineers dreamed of: complete access to enemy weapon systems, with unlimited opportunity for study and analysis. The centerpiece of this effort in the Western zones was Aberdeen Proving Ground in Maryland. This vast military facility had been established during World War I as a place to test artillery and other weapons, and by World War II it had expanded into one of the most important proving grounds in the entire American military establishment. The facility sprawled across thousands of acres of Maryland terrain, with test courses, firing ranges, and extensive workshop facilities capable of conducting comprehensive testing on massive weapon systems. The infrastructure at Aberdeen represented decades of investment in weapons testing capability. Beginning in late 1945, the United States Army began shipping carefully selected examples of German tanks to Aberdeen for detailed study and evaluation. A Panther arrived, then a Tiger Wings, that most feared of German heavy tanks throughout the war. A Tiger II followed, the even more powerful successor design. The Jagdpanther, a powerful tank destroyer variant built on the Panther chassis and mounting a formidable 88mm gun, was shipped across the Atlantic. Several assault guns and self-propelled guns came as well. These vehicles weren't simply placed on display or stored away. American engineers conducted exhaustive gunnery tests, firing the tank's main guns to understand their ballistic performance in precise detail, measuring muzzle velocity with special equipment, examining shell trajectories, and assessing penetration capability against various armor thicknesses. Mechanical trials evaluated the reliability of engines, transmissions, and suspension systems under simulated field conditions. Engineers would run the engines and test the transmissions, looking for signs of mechanical weakness or engineering excellence. Armor penetration studies measured the thickness of German plate steel with precision instruments, assessed how effectively the sloped armor design worked against incoming fire, and tested it against American anti-tank weapons to understand comparative lethality. The results of these tests revealed patterns that would become characteristic of German tank design and would shape military thinking about tank development for decades to come. The American reports consistently found that German tanks possessed excellent firepower. Their main guns had high muzzle velocity, flat trajectories, and impressive armor penetration capability that exceeded contemporary American weapons. The optics on German tanks were of remarkably high quality, far superior in many respects to what American tank crews had available. German tanks featured sophisticated fire control systems and optical instruments that represented the finest German optical engineering, products of the precision manufacturing traditions of companies like Zeiss and Leitz. But there was a persistent and significant weakness. German tanks suffered from chronic mechanical failures, particularly in their final drive systems and gearboxes. The transmission that transferred power from the engine to the tracks was prone to overheating, seizure, and catastrophic failure under combat conditions. It was a trade-off that the German engineers had apparently accepted, brilliant firepower and optics at the cost of mechanical reliability and ease of maintenance. For American engineers, this was an important lesson that would influence tank design philosophy for the next generation. As they designed tanks for the future, they would prioritize simplicity and reliability alongside firepower, understanding that a tank that runs reliably is worth more in combat than a technologically sophisticated vehicle prone to breaking down. The British conducted similar evaluations, though their testing was mostly conducted within Germany itself rather than shipping vehicles overseas. British engineers were particularly interested in the Panther's sloped armor design and its long-barreled main gun. They noted the exceptional quality of German optical systems, but they also recorded how difficult it was to maintain and repair German vehicles under actual field conditions. The complexity of German design made simple maintenance almost impossible. These British evaluations would influence early Cold War thinking about tank design, but they didn't lead directly to the British building German-style tanks themselves. The lessons were absorbed, but the British military chose to develop a different design philosophy. The Soviet Union approached the problem quite differently. Rather than shipping German tanks to testing grounds thousands of kilometers away, the Soviets relied on trophy brigades that collected large numbers of captured Panzer IVs, Panthers, and assault guns, primarily for training purposes. Soviet test results confirmed what their troops had already observed during the war. German tanks had strong frontal armor and high-velocity guns, but mechanical systems that deteriorated quickly under harsh conditions. By the early 1950s, most captured German tanks in Soviet hands had been scrapped once spare parts became impossible to obtain. The Allies also discovered remarkable things at former German research facilities. At Kummersdorf and Hillersleben, sites where the German military had conducted armor research and development throughout the war, Allied teams found incomplete hulls and experimental vehicles that represented the cutting edge of German tank development. These included components from the Maus program, the German super heavy tank project that had produced only 2 prototypes before the war ended. Parts of the planned E-Series tanks were discovered as well, a theoretical family of vehicles that were supposed to standardize German tank production. At Haustenbeck, workshops held damaged Jag Tigers, Panthers awaiting repair, and crates of spare parts that provided evidence of late-war engineering that never reached full production. Final disposition policies, different Allied approaches. Early occupation directives required all German armored vehicles to be reported, secured, and restricted from unauthorized use. This triggered a significant debate among Allied planners during 1945 and 1946. The fundamental question was deceptively simple, but strategically complex. Should the tanks be preserved for study, transferred to other nations as military aid, or destroyed to prevent future militarization? Each Allied power pursued different priorities based on their strategic interests, industrial capacity, and geographic position in the post-war world. The United States, emerging from the war as an industrial giant with unparalleled manufacturing capacity, prioritized technical testing and knowledge acquisition. American planners understood that German tank design represented years of accumulated experience in armored warfare and could provide valuable insights into future vehicle development. The U.S. military wasn't desperately dependent on captured German tanks to equip its forces, since American factories could produce unlimited quantities of American-designed vehicles. But American planners were intensely interested in understanding how German engineers had solved certain technical problems and in learning from German mistakes regarding mechanical reliability. This attitude of scientific curiosity and technical interest meant that American occupation forces systematically collected the best examples of German tank design and shipped them to testing facilities. The Soviet Union, facing a recovering Germany in its occupation zone and deeply concerned about future German militarization, took a harder line on demilitarization while simultaneously collecting as much technical intelligence as possible. Stalin was paranoid about potential German rearmament and was determined to ensure that the Germans could never rebuild their war machine. At the same time, Soviet military planners wanted to study German technology to understand how to improve their own designs. The Soviets engaged in a form of technical piracy, meticulously examining captured German equipment and incorporating successful design features into Soviet vehicles. The T-34-85 successors and the development of heavy tank designs were all influenced by knowledge gained from studying captured German armor. Britain, with its limited industrial resources and extensive overseas commitments, took a pragmatic middle position. British planners understood the value of technical knowledge but lacked the manufacturing capacity to build tanks in the quantities that Soviet and American planners could. British evaluations focused on understanding design principles and operational characteristics rather than on comprehensive testing. Britain was more interested in preserving a few key examples of advanced German technology for post-war study than in accumulating large collections of captured equipment. France, still rebuilding its military after German occupation and defeat, had a different agenda entirely. French planners understood that they needed modern tanks to re-establish their military position in Europe. Since French tank factories had been damaged during the war and would take years to restart production of domestic designs, captured German tanks represented an immediate solution to French armor deficiencies. The French systematically collected Panthers from depots in their occupation zone, understanding that these advanced vehicles could bridge the gap until French domestic production could resume. This practical approach meant that France, more than any other major Allied power, relied on captured German armor to equip its early post-war military forces. These divergent approaches shaped not only the immediate post-war military balance, but also influenced the long-term trajectory of tank development in all the major powers. American knowledge about German firepower and optical systems influenced the development of the M47 and M48 Patton series, with their emphasis on powerful main guns and comprehensive fire control systems. Soviet study of German armor contributed to the development of increasingly sophisticated tank designs throughout the early Cold War period. British design philosophy, influenced by observations of German complexity and maintenance challenges, emphasized reliability and ease of maintenance. French exposure to the Panthers' capabilities directly influenced the development of the ARL-44 and later French tank designs that borrowed heavily from Panther concepts in areas like sloped armor and powerful main armament. The systematic destruction, demilitarization, and industrial salvage. By 1946, the Allies faced a reality that couldn't be avoided through testing or study. They possessed thousands upon thousands of tons of German military equipment: tanks, armored vehicles, spare parts, unfinished prototypes, and components scattered across the former Reich. Storing all of this indefinitely was prohibitively expensive. Maintaining it required resources that were desperately needed elsewhere, and there was a political and strategic imperative that drove every occupation decision. Germany was not permitted to rebuild its military forces under any circumstances. The occupation directives from the Allies were explicit on this point. Every German armored vehicle had to be reported, secured, and restricted from unauthorized use. In principle, none of them should remain in German hands. In practice, that meant they had to be destroyed on a massive scale. Between 1946 and 1948, the Allied Control Council issued a series of increasingly strict directives that placed all German military equipment in the category of prohibited materials. Tanks, armored hulls, and vehicle components were officially classified as items that could not be allowed to remain in the hands of German citizens or be used for any future rearmament. This classification triggered the largest systematic demilitarization and scrapping effort the world had ever seen, dwarfing any previous disarmament efforts in history. The decision wasn't made lightly or without consideration. Military planners and political leaders understood that German tank design had been innovative and sophisticated. There was strategic value in the knowledge contained in these machines. But there was also a clear strategic necessity to eliminate any possibility that Germany could rebuild its military capacity. The Allies had won the war at tremendous cost in blood and treasure. They weren't willing to risk the emergence of a rearmed Germany in the near future. The industrial centers of the German heartland became the focal points for this massive scrapping operation. The Ruhr Valley, which had been the industrial core of Nazi Germany throughout the 19th and 20th centuries and had been systematically bombed during the war, was selected as a primary site for tank destruction. Saxony and Thuringia, regions with significant steel production capacity, were chosen as well. Steel plants in Bochum, Essen, and Magdeburg began, receiving long, seemingly endless lines of armored vehicles delivered by occupation forces. Tanks would arrive by rail from nearby depots, towed by locomotives carried on flat cars, transported by trucks from collection points, Workers with cutting torches and heavy machinery would reduce Panthers, Panzer IVs, and Stugs assault guns into pieces of scrap metal. The work was methodical and industrial in scale. There's something almost surreal in photographs from this period, showing rows of German tanks being fed into the hungry maw of industrial destruction, machines that had terrified Allied soldiers just months before being reduced to scrap metal and melted down into anonymous ingots. Germany, at this time, was desperately poor. The economy had been destroyed by war, by bombing, by the disruption of trade, and by the loss of so much industrial capacity. Germany needed raw materials to rebuild its shattered infrastructure and feed its population. The recovered metal from the scrap tanks went directly into rebuilding the infrastructure that the war had destroyed. Bridges that had been bombed out during strategic bombing campaigns, factories that had been flattened by Allied air attacks, housing that had been obliterated by years of aerial bombardment. By late 1947, hundreds of armored vehicles had been melted down in these steel plants, leaving little trace of their wartime role. The tank that had been a formidable weapon of war became the metal that framed a German family's new home, that formed the beams of a rebuilt factory, that made possible the reconstruction of a devastated nation. But scrapping wasn't the only method of disposition. Not all captured German tanks were sent to steel plants. In many rural areas across Central Europe, Allied engineers found practical uses for abandoned armor in ways that seemed almost incongruous and creative in retrospect. One well-documented example occurred along the Enns River in Austria. In Ossu, this location, Allied engineers used bulldozers to push captured Panthers and other tanks directly into embankments, where they served to stabilize the riverbanks and prevent erosion during spring floods. The physics of it made practical sense. Large, heavy metal objects could function as structural fill material and provide weight and stability that prevented the banks from collapsing. Similar practices occurred in quarry sites across Central Europe, where tanks served as fill for areas prone to landslides and geological instability. Over time, soil accumulated over these remains, and vegetation grew across them. The machines that had been engines of war became literally part of the landscape, buried under earth and grass, their metallic frames slowly oxidizing in the Austrian and Czech soil. Another significant share of surviving German armor served a different but equally important purpose in the post-war world. These vehicles became target hulks for live-fire training exercises. The British used captured tanks as targets at ranges like Lulworth in England. The Americans conducted similar exercises at Grafenwohr, and of course at Aberdeen Proving Ground in Maryland. The Soviets used German vehicles at various training sites across the occupation zones. These tanks allowed military crews to test new ammunition types, to practice gunnery techniques in realistic conditions, and to evaluate the effectiveness of emerging anti-tank technologies. Crews would set up a captured Panther or Tiger as a target and repeatedly fire at it with different weapons to understand how effective the new munitions were against armored protection. It was a practical and efficient way to use equipment that would otherwise have been destroyed, while simultaneously gathering valuable data about weapons performance that would inform future weapons development. Clearance operations continued in battle-scarred regions where vehicles had been abandoned during the final months of the war. Czechoslovak and Polish teams worked to remove wrecks from roadsides and forests, from former defensive lines and improvised fortifications. These recovery teams would gather the damaged and abandoned tanks, transporting them either to scrap yards for dismantling or using them in land reclamation projects. The work was exhausting, dangerous, and unglamorous, but it was necessary to restore the landscape to civilian use. The scale of this demilitarization was truly staggering. The numbers were simply enormous. By 1948, the vast majority of Germany's wartime armored vehicles had been destroyed. Myths sometimes circulate among tank enthusiasts about secret storage bunkers filled with pristine Panthers or hidden warehouses containing undamaged Tigers, tucked away in remote locations and waiting to be discovered by future researchers. But the available historical evidence points consistently to misidentified structures or Cold War-era rumors with no factual basis. The reality is that most of Germany's wartime armored fleet was systematically and thoroughly destroyed. The German tank fleet that had once dominated European battlefields had been dismantled, piece by piece, converted into scrap metal, buried in riverbanks, or used as target practice. Second lives, German tanks in foreign service. However, not every captured German tank went into a furnace or became part of a riverbank structure. A smaller but genuinely significant number found what might be described as a second life, pressed into military service under new flags and in new nations. These vehicles filled critical gaps for countries that lacked modern armor or urgently needed equipment without the resources to purchase or manufacture new machines. Their post-war service would extend the operational life of these German designs well into the 1950s, and, in some surprising cases, even into the 1960s. The spread of German tanks to foreign armies represented a global dispersal of Nazi military technology, creating a legacy that extended far beyond Germany's borders. France was among the earliest and most intensive users of captured German equipment. French forces systematically collected Panthers from depots and storage areas in southwest Germany, understanding that these advanced vehicles could provide the firepower and protection that French forces desperately needed while domestic production restarted. These tanks were incorporated into the 503rd Combat Tank Regiment and the 6th Cuirassier Regiment, units that would become instrumental in rebuilding French armored capabilities during this critical period of reconstruction. French crews who operated these Panthers quickly came to appreciate the firepower and optics of the German machines, which generally surpassed the Allied tanks available to them at that moment in history. The Panther's sloped armor was impressively effective at deflecting incoming fire, and its main gun had power that the early post-war American tanks didn't match. Approximately 50 Panthers were placed into operational service, operating alongside American-supplied Sherman tanks. The 503rd even conducted maneuvers with these German machines in 1947, allowing French soldiers to train with captured German equipment and develop tactics for operating them. But appreciation for the Panther's qualities didn't translate into a long-term solution to France's armor requirements. Maintenance challenges emerged almost immediately and grew progressively worse with each passing month. The French didn't possess a comprehensive supply of spare parts because they had no factory access to components. The complex mechanics of the Panther's drivetrain, particularly that notorious final drive that had plagued German crews throughout the war and continued to be a source of endless mechanical frustration, continued to bedevil French mechanics with relentless consistency. French mechanics found that working on a Panther required extensive technical training, specialized tools, and intimate knowledge of the vehicle's complex systems. French workshops developed a strategy of cannibalization out of pure necessity, carefully dismantling multiple worn-out or damaged Panthers to keep a smaller number of machines running. Parts from one tank's engine might be salvaged to repair another tank's mechanical systems. Parts from damaged transmissions would be harvested to keep functioning tanks mobile. Reports from the early 1950s described mounting transmission issues that became so severe and so frequent that by 1951, France made the decisive decision to retire the last of its Panthers. The maintenance costs had become absolutely prohibitive. The constant need for repairs, the difficulty in obtaining replacement parts, and the sheer complexity of keeping these machines running in operational condition had won out. The experience of operating Panthers influenced French thinking about tank design during a crucial period when the country was reestablishing its military capabilities after years of German occupation and military humiliation. Czechoslovakia played a particularly unique and important role in this post-war story because the nation had been a major manufacturing center for German armor during the war itself. When Germany occupied Czechoslovakia in 1938, the entire Czech industrial base was incorporated into the German war machine. The Skoda factories, which had produced Czech-designed tanks before the war, were repurposed to manufacture German tanks and tank components. When the war ended and Czechoslovakia was liberated by Soviet forces, something remarkable happened. The factories continued operating with Czech workers and engineers, but now resumed production of the Hetzer, a tank destroyer based on the Czech chassis. Many of these post-war Hetzers were sold to Switzerland, which operated them well into the Cold War era. The combination of simple mechanics and reliable engines made the Hetzer suitable for smaller nations seeking cost-effective armored firepower. Czechoslovakia also found uses for leftover Panzer IVs and assault guns in its own military before gradually replacing them with Soviet-supplied designs as Cold War alignments solidified. In Eastern Europe, countries in the Soviet sphere of influence received German vehicles, either captured during the war or redistributed through Soviet trophy brigades as part of Stalin's strategy to arm Allied communist states. Romania operated Panzer IVs for training purposes, using these machines to train crews in armored tactics and to conduct field exercises. Bulgaria integrated a mixture of Panzer IVs and assault guns into its early post-war armored units. For a brief window in the late 1940s and early 1950s, German tanks served under the flags of nations that had themselves suffered terribly under German occupation just years before. By the mid-1950s, most Eastern European users had shifted fully to Soviet-supplied T-34 tanks and newer armored vehicles. The brief chapter of German tanks in Eastern European service came to a close. Spain presented a different case entirely. In 1943, Germany supplied Franco's government with 20 Panzer IVs and 10 Stughi assault guns as a tangible expression of solidarity between fascist regimes. The Panzer IV remained Spain's premier tank well into the mid-1950s, operating alongside older Panzerleutnant tanks. As maintenance grew difficult and spare parts became impossible to obtain, the Spanish fleet contracted in size. By 1967, Spain still possessed 17 surviving Panzer IVs from that original 1943 shipment, vehicles that had lasted more than 2 decades in military service. These aging machines were sold to Syria, extending the operational life of these nearly quarter-century-old vehicles into the Middle East and a completely different regional conflict. The case of Syria is one of the most unexpected and fascinating chapters in post-war German tank history. During the 1950s and 1960s, Syria acquired Panzer IVs from both Czechoslovakia and Spain, positioning them in frontline units along the Golan Heights, the strategic territory that overlooked Israeli settlements and agricultural areas. During the 1965 Water War, a limited conflict with Israel, these German tanks opened fire in anger for what was likely the final time. They remained in service into the 1970s, marking one of the last known operational uses of a German World War II tank in combat operations. The presence of these German vehicles in Middle Eastern service reflects the global circulation of surplus armor in the early Cold War period, as newly independent nations sought affordable military equipment amid emerging regional tensions and conflicts. The role of spare parts scarcity cannot be overstated in determining the long-term fate of these post-war German tank fleets. Nations that operated captured German tanks found themselves confronting the same fundamental problem: parts. They could rely on captured depots and storage facilities, but these supplies eventually ran out completely. Czechoslovakia, with its industrial traditions and factory experience, was better positioned than most nations to manufacture replacement components. Mechanics in other countries often had to fabricate components using improvised solutions. Training crew members became difficult without proper instruction materials written in local languages. Yet despite all these challenges, the tanks influenced early Cold War doctrine profoundly. By the mid-1950s, most countries had retired their German vehicles in favor of standardized equipment supplied through either the United States or the Soviet Union. Preservation and memory. Where German tanks survive. While most German tanks were destroyed or scrapped, a thoughtful decision was made to preserve examples of the most important designs. Surviving Panthers, Tigers, and Panzer IVs entered museum collections where they could be studied, displayed, and preserved for future generations. These institutions understood that they possessed not merely military hardware, but artifacts that told the story of technological innovation, of tactical choices, of engineering under pressure, and of the terrible human costs of industrial-scale warfare. The Tank Museum at Bovington in England maintains an important collection that includes multiple German tanks. The Musée des Blindés in Saumur, France, holds excellent examples of German armor that allow visitors to understand how the sophisticated machines actually looked and functioned. The Kubinka Tank Museum near Moscow in Russia has preserved key examples that represent Soviet perspectives on German tank design and technology. These institutions serve as guardians of these mechanical artifacts, ensuring that the physical embodiment of German tank engineering is not lost to time, corrosion, or simple neglect. The work of preservation isn't simple or inexpensive. These are massive machines made of steel that will rust and deteriorate if left to the elements. They require careful conservation work to prevent further damage, regular maintenance to keep critical components from seizing, and sometimes complete restoration to return them to something approaching their original condition. Museums have invested substantial resources in these efforts because they understand that these physical objects serve as irreplaceable teaching tools. When a visitor stands in front of an actual Panther tank, they understand something about the engineering sophistication and the size and power of the machine in a way that no photograph or written description could convey. Some of the restored tanks have even returned to running condition, though this is rare and requires extraordinary effort and dedication from dedicated mechanics. Mechanics working on these restorations have had to source components from multiple vehicles, to improvise solutions when original parts were no longer available, and to carefully reconstruct mechanical systems from photographic evidence and surviving technical documentation and original blueprints. The fact that some of these nearly 8-decade-old machines can be coaxed back into operational status speaks to the fundamental engineering quality of the original designs, despite their mechanical failings. Legacy and design influence. How German tanks shaped the future. The influence of captured German tanks on post-war tank design cannot be overstated. Every major military power that examined German armor drew lessons that influenced their subsequent development programs. American tank designers incorporated observations about German gun performance and armor protection into the development of the M47 and M48 Patton tanks, which featured increasingly powerful main guns and better fire control systems, influenced by studying captured Panthers and Tigers. The sloped armor concept that the Germans had pioneered became standard in tank design worldwide. British designers, after evaluating German tanks, emphasized reliability and ease of maintenance in their subsequent designs. Soviet engineers examined German designs intensively and incorporated successful design features into their own development programs. The tank designs that emerged from the 1950s onward in every nation that had studied captured German armor showed clear evidence of lessons learned from examining Tiger, Panther, and Panzer IV designs. The broader lesson that every nation drew from post-war tank evaluations was the importance of balancing competing design requirements. The Germans had emphasized firepower and protection at the cost of reliability and ease of maintenance. Post-war designers worldwide sought to maintain German levels of firepower and protection while improving reliability. This drive to balance multiple design requirements shaped tank development throughout the Cold War period. The debate between heavy tanks and medium tanks was influenced by experiences with German tank designs. The question of how much armor protection was necessary, what caliber of gun was required, how fast a tank needed to be, all of these decisions were informed by knowledge gained from studying captured German armor. Conclusion: reckoning with Germany's arsenal. The story of what happened to Germany's tanks after World War II is a multifaceted tale that encompasses military science, industrial policy, international relations, and the practical challenges of managing an enormous military arsenal at the conclusion of a devastating conflict. There was no single answer to the question of what would happen to thousands of German tanks. Instead, there were multiple answers that reflected the different priorities and circumstances of the occupying powers and the nations that acquired German equipment. Each nation approached the problem differently, based on its own strategic interests and military needs. The Americans sought technical knowledge, conducting exhaustive tests to understand German design philosophy and to identify lessons that would shape the development of American tanks for decades to come. American tank designers would study captured Germans' vehicles for months, documenting every detail of their construction, testing their weapons, analyzing their armor protection. The British observed, evaluated, and documented their findings, recording both the strengths and weaknesses of German engineering with characteristic thoroughness. The Soviets collected vast quantities of equipment, used it for training purposes with their forces, and then scrapped it when spare parts became impossible to obtain. The French put captured German tanks into operational service, learning hard lessons about the costs of complexity and the challenge of maintaining sophisticated equipment without adequate supply chains. Smaller nations cobbled together fleets from whatever equipment they could obtain, extending the operational life of German designs in ways that the original designers surely never anticipated. For countries like Syria, Tanks that were nearly 30 years old at the time of their use represented the best armored vehicles that their military could obtain. The vast majority of German tanks were systematically destroyed as part of the Allied policy of complete demilitarization. Industrial plants melted them down for scrap metal that helped rebuild a shattered nation. Riverbanks were stabilized with captured armor that sank below the soil and vegetation. Training ranges fired countless rounds at tanks that had terrified soldiers just months before. This systematic destruction was a strategic necessity. The Allies were determined to prevent German rearmament, and they were willing to sacrifice the enormous monetary and material value of these machines to achieve that goal. Thousands of vehicles that had cost enormous resources to manufacture were deliberately destroyed because the price of preventing future German militarization was worth any amount of material waste. Yet some tanks survived. Preserved in museums, these machines stand as testimony to the sophistication of German engineering, to the choices made by German designers, and to the technological competition that shaped the Second World War. They represent not merely weapons of war, but artifacts of human ingenuity applied to the terrible purposes of combat. They remind us of the scale of the war, the industrial capacity that was devoted to its prosecution, and the challenge of managing that vast material legacy in the aftermath of conflict. Each preserved tank is a connection to that era, an opportunity for future generations to understand what mechanized warfare was actually like. If you found this exploration of what happened to Germany's abandoned tanks after the war to be fascinating, I'd encourage you to consider what other questions remain unanswered about the immediate post-war period. The fate of German aircraft, German submarines, German research facilities. All of these topics contain similarly complex and interesting stories about the challenges of managing the material legacy of war and occupation. The post-war disposition of Nazi Germany's military equipment is a window into how victorious powers manage the material consequences of defeat, how military technology is evaluated and studied, and how industrial capacity is redirected from warfare to reconstruction. I'd like to thank you for spending this time with me exploring these questions. If you enjoyed this video, please consider liking it, subscribing to the channel, and hitting the notification bell so you don't miss future explorations into the fascinating details of World War II history. We dive deep into stories like this regularly, examining the often overlooked aspects of the war and its aftermath that shaped the modern world. Your support helps us continue creating this content. Thanks for watching, and we'll see you in the next video.